Hi, my name is Joshua Miller. My wife, Shannon Miller, is the director for CC Rainbow Monday in California. And we're going to go over our next science experiment, which is number 88, Tug of War. Now, if you'll go back and review number 86, the where did it go, you'll kind of remember some of the things we talked about covalent bonds and hydrostatic bonds. But as a quick, super fast review, if we have Minnie Mouse here, the water molecule has oxygen and hydrogen. So the hydrogens are the smaller ones. It actually looks just like a Mickey Mouse, head and ears. So we've got the oxygen is the bigger one, and the hydrogens are the smaller ones. Now there's a weak bond between the hydrogen and other oxygens, but a strong bond between the oxygen and the hydrogen. Now, why that's important and why that's significant is it makes it so that water has what is called surface tension. Water sticks to itself. If you've ever gone and taken a nickel and taken an eyedropper and dropped droplets of water on it, you can see that the water will form a bubble. It's actually sticking to itself, surface tension. It's a very weak bond. That's the hydrostatic bond. There's space in between each of the molecules because they have the strong bonds and the small bonds. There's actually space in between different molecules. Kind of like, I know these are different sizes, but we would have a hydrogen and an oxygen attached over here, but then this one has hydrogen and oxygen, and maybe you'd have another one over here, maybe another one over here. So there's actually space inside of, in between each of the different water molecules. Water is actually known to be the best absorber of any other liquid substance. It can absorb lots of things. I don't know if you've ever gone and put salt in water. The salt will absorb in the water, or baking soda, or you can mix lots of different things into it, and they'll absorb into it. So what this experiment is showing is we're going to do that with some rubbing alcohol. So I have some 91% isopropyl alcohol here. I've already gone and made my water with some blue food coloring. We made a dark sample of it so that we can see it. I'll set that aside. I've got a piece of aluminum foil right here that we're going to put on here. Now, in the book it says to use an eyedropper. Now, you don't technically have to use an eyedropper. You can use a pipette. An eyedropper is pretty much the same as a pipette. It's made of glass. It's usually shorter, and it has a little rubber head, whereas this is all just plastic. It's just for grabbing some of the stuff and dribbling it on here. Now, what you want to do is you want to make this as thin as possible. So we're going to put this on here. Hopefully no bubbles. We're going to put this on here. Try and get it as thin as we can. The thinner that it is, the better. So we'll see if we can kind of spread it out a little bit. If your table's really nice and flat and level, it'll work better as well. My table's a little off kilter right now. As you can see, the water's flowing in one direction. So then what we're going to do is we're going to take some of our rubbing alcohol. And I forgot to open it. There we go. And we're going to get just a little bit of our rubbing alcohol. And what we're going to do is we're going to put it in the center. Now, what's going to happen once it gets into the center, watch carefully, is we're going to put it in the middle, and it's going to push away all of the water. Now, what's going to happen is the water's going to slowly absorb it, and you'll kind of see the water kind of moving and bubbling a little bit. It kind of looks like, I don't know if you can see when you're looking real close, it looks like it's moving. I'm not touching the table. There's not an earthquake going on here, at least not the one that we're aware of. But the water is and the rubbing alcohol are kind of bumping against each other. What's happening is the water is trying to stick to itself, so it has the surface tension going on, but then at the same time the rubbing alcohol is trying to go, and it's trying to go into the water. It's trying to be absorbed by the water. So that movement that we see, eventually, if we waited long enough, all of this would be one big bubble again. And it works, like I said, a little bit better if you're on a flat surface. We'll try and do it right here, maybe a drop here. Put it, there we go. Whoops, I guess we kind of mixed that really fast. But you kind of see the coloration difference. You see how it's kind of like moving around? It's mixing it together because the rubbing alcohol is being mixed into, and it's being absorbed into the water. You can really see it really good right there.
Don't shadow.
Now when the two liquids are completely mixed together as much as they can be, all of that movement, the water movement, will stop. There you go. Kind of see it right there, getting absorbed in there. It's going, see how it's getting smaller, 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 smaller. We'll do it another time over here. Another drop. The water's trying to absorb it. And that's because of the space between the molecules of water.
Thank you.
Hey everybody, as a little follow-up on experiment number 88, Tug of War, Shannon and I, my wife and I were talking after we filmed the video, and we realized just a couple little things. One, it would be a lot easier if you used a ceramic plate, like a Corelle plate. Apparently in the experiment book it says to use the aluminum foil, and it doesn't work as well as a Corelle plate. So go ahead and try that. You'll probably be able to see it a little bit better. Also, we were filming out in our driveway, and it's a little bit angled, and so the water was flowing to one side. So make sure it's a real flat surface, and you'll really be able to see that swirling effect. Now, something that you can do to kind of stretch out the experiment, because we know Cece wants us to do this with the kids for a half an hour, and sometimes it's like, how am I going to stretch this experiment out? Something that, like a little extra activity that you could do to show the kids the surface tension of water and kind of what's happening between the alcohol being absorbed into the water, is you can break the kids up into individual atoms and then make molecules with them. So if you had, say, a piece of paper and you wrote a O on it for some of your children, and then you wrote H on it, the oxygens and the hydrogens for the water molecules, then you can maybe have some double-sided tape or something, tape it to their shirt or something. So you have a couple kids that are oxygens, and you have maybe, say, 4 kids that are going to be your hydrogens. And what you can do is you can actually show them the difference between, oh, I'm an oxygen atom, and oh, I'm a hydrogen atom. But now if we take 2 hydrogen atoms and we bring them over next to the oxygen atom, now the oxygen atom has that covalent bond, that strong bond. So what you'll want to do is those 2 hydrogens will stand there, and the oxygen atom will grab their arms, maybe like right at the wrist, really strong. So there's that strong covalent bond. But now the 2 hydrogens of that now water molecule, so you have a water molecule, those 2 hydrogens, now they can reach out and they can touch the oxygen from the other water molecule that you've created. So say you have 6 kids, so you can create 2 water molecules. If you have 9 kids, obviously 3 water molecules. But each of the individual atoms have the different bonds. The oxygens are the one oxygen child is going to be holding strongly onto the hydrogens, and then the hydrogens are going to go maybe just go and rest their hands or something, just a gentle touch, maybe even just 2 fingers, however you want to do that, to another water molecule's oxygen. And that's the difference between the covalent bond that the oxygen has with the hydrogens and the hydrostatic bond, the weak bond between the hydrogens and the oxygens of other water molecules. And that's what creates the surface tension. And so what you can do then is you can have your group of atoms, now 2 molecules or 3 molecules of water, kind of blob around, and you, as the tutor, be the rubbing alcohol that's trying to get in the midst of them. So if you go and you try and bump into the oxygen grabbing onto the hydrogen, you're not going to be able to break that covalent bond, but it will be easy for you to kind of break into their blob and go into the middle of them in the where the hydrogens are holding on weakly to that oxygen. And you can explain that to the kids and let them know that that's the difference between those 2 bonds. That's why water has surface tension, and a lot of the experiments a lot of experiments deal with the surface tension of water. If you've ever floated a paper clip on the surface of a water, or taken a nickel and made a big bubble by dropping drops of water on it until the drops break, you can actually look sideways on a nickel, and I mean you can get you can get almost a 1/4 inch of water on top of a nickel. That's the surface tension of water. That's that stickiness. That's the hydrogens holding weakly onto the other oxygens. That hydrostatic bond. So there's something you can do to kind of stretch that out. Have fun chasing the kids around the yard as the rubbing alcohol, trying to absorb yourself into the the midst of the blob of children. Have fun with that.